Step 2. From the above obtained weight, L of t equals to W of a comma t, select the vertex in T that has the smallest index with respect to T. Now we have to find the value which is having the minimum value among various W of a comma t, where t belongs to T, and denote this smallest or minimum weight, and we denote this smallest weight as a x. Step 3. If the index or label of vertex z, then stop the algorithm, and the path p union of z will be shortest path. Otherwise, p dash equals to p union of x and t dash equals to t minus x for every t belongs t in T. We compute its smallest index with respect to p dash using the relation. Now we use the relation. After finding the weight of index of initial vertex, then we use for the remaining vertices from A to remaining vertices. How we find? The formula is L dash t equals to, this is the formula, L dash t equals to minimum of curly brackets L of t comma minimum of L of t comma L of x plus W x comma t. This is the formula for finding the index of various vertices from A to other vertices. Now we use this relation. So we have two main formula here. First is L of t equals to W of a comma t. This is for initial vertex, and for the remaining vertex other than A, we use this relation L dash t equals to minimum of L of t comma L of x plus W of x comma t. Now repeat the step 2 and 3, and repeat until we have reached to the vertex z. Until we have to reach to the final vertex z, and stop the algorithm. This is the end of algorithm. So we have total 4 steps in Dijkstra algorithm. We already discussed here. Now we take an example ki how we find the shortest path of the given graph, and this is the very important part ki how we find the shortest path using Dijkstra algorithm. We have to remember two formula here. First is L of t equals to W of a comma t, and another is L dash t equals to minimum of L of t comma L of x plus W of x comma t. Now we consider an example here. Now we write this example here. Now this is A to B, vertex A, this is B, this is C, and one vertex is directly to Z. Okay, and we have to find B. Here is C. Okay, directly. Okay, so this is okay. Sorry. A to B, this is your C, and this is your D, this is E, and this is F and 0. The length, the weight on A to B is given 22, this is 10, and this is 8. So A to B, the weight is given 22. Then B to C is 20, and C to D is 10, and from B to E is 2, this is 4, from C to Z 10, from B to F is 7, and from C to E is 4, and from C to F is 3, and another H from B to Z, and this is 2. This is the length of this edge is 2. So this is the graph, and we have to find the shortest path from A to Z. Okay, now we start Dijkstra algorithm. First we consider the vertex set. Here vertex set is V equals to vertex set V equals to A comma B comma C D and E F and Z. This is your vertex set. Vertex set is A comma B comma C comma D comma E comma F and Z. Okay, now we start with step 1. Step 1 is, let's consider starting vertex as A, and so we create a path by taking this P equals to A. This is the path, starting vertex, and the remaining vertices in T are, the remaining vertices are T are T equals to V minus S. You have to remove A here, so we get T equals to, the other vertices are B, C, D, E, F and Z. These are the other vertices. So our path is P, starting vertex we are taking, and the remaining vertices are B, comma C, comma D, E, comma F and Z. The next step is, now for every T in T, very T is small t to capital T, we compute smallest index from A to all other vertices in T. So now we have to find the weight of the edges from A to all other vertices, or it is given by, the relation is L of T equals to W A comma B. We are using this formula here. Okay, so what will be the weight, smallest index? What is the index of the vertex A to B? Here we check here. Here T belongs to T, so we are taking here T equals to A. So W A comma B, the formula is, we have already written here, L of T equals to W A comma T here. So here we are taking the first element of capital T, which is B. So what is the index of W A comma B? So here the distance is given 22. So W A comma B equals to 22. They are directly connected. They are adjacent to each other. So we put the number 22 here. Now for T equals to, the another element is T equals to C. So this will be W A comma C, and this is A comma C. They are adjacent to each other. So we put 10 here. Then T equals to D. So W A comma D equals to, this is the 8. They are directly connected to each other. Now W A comma E, we have to find the index from A to all other vertices here. So W A comma E, they are not adjacent to each other here because B is there. So we put infinity. W A comma F, they are not adjacent to each other. So we put infinity, and W A comma Z, they are not adjacent to each other. So we put infinity. Hence, the finite indexes are, that is 22, 10 and 8. So, and the remaining index for A to E, A to F and A to Z is infinity. So these are the smallest index. Now, these are the index. Now we have to find the smallest index among these index. Now select the smallest index from the above. In our case, the smallest index vertex is D equals to 8 here. Here we get this is the minimum value, smallest among all index. So we take, this is the for the vertex D. So the smallest index is for D, which is 8. So we select vertex D for the labeling, and we put x equals to A. Yeah, we take x equals to D here. X equals to D. Now next. Now after selecting the D, our path will be increased here. our path. What will be our path? We denote this path as P dash equals to P union of the vertex which is be chosen here, D, equals to the now path will be A to Z. A to Z, and T dash, that means T minus vertex D. The remaining vertex set is which will be B, C, E, F and Z. B, C, E, F and Z is the remaining vertex. And now again we have to compute the smallest index among B, C, E, F and Z. And what will be? It will be, we see here,